Welcome to the presentation on Mordor. This one's going to be about the streams library in Mordor and what's in there, what it can do, and why you should even want to use it. So what is a stream? Stream is just an abstraction of data flow. It's, a socket is a stream. A file is a stream. It's a bunch of bytes coming. And they're stackable layers, meaning that you can modify the behavior of a stream by stacking additional filter streams on top. And the critical point is streams stream. There's no, hey, let's read the whole file into memory just so we can compress it. We want to compress as we're reading the file into memory, as we're sending it on the socket. So we're not using memory. It's a lot faster because we're not waiting for each step to complete. So they need to stream. Zero copy if possible. So the streams in Mordor use a buffer object, which manages the memory, and it's a chain of buffers so that when it needs to allocate more, it doesn't have to reallocate the whole thing. It just allocates more and adds it to the chain. And they're shared between the different ones so that when you write from one stream to another, it doesn't have to copy unless it absolutely needs to. So there's a couple different types of stream. There's the base streams. That are the ones that actually provide or consume data. So a socket is a base stream. A file is a base stream. Filter streams either change, add, or remove features. So the penultimate example of this is the buffered stream. It adds lots of extra features that you wouldn't have without buffering, besides just buffering, because buffering is very, very useful to increase your throughput. The other thing they can do is they can mutate data, which means change the data as it's flowing through. There's a couple of those. Great example is compression. There's a zlib stream that changes the data, compresses it as it flows through. And then conceptually, you can look at streams. There's random access streams that you can seek around in, and they may or may not change, but the position of the stream for both read and write is linked, and you can seek around. Or a full duplex stream is like a socket where they're not seekable, and reading what you read is not necessarily what you write. So they're two separate streams flowing in opposite directions. Okay, EOF handling. An EOF happens when you're reading when read returns 0. You could query to see if where your current position is equal to the end of the file, but that's not the definitive way to see if a stream has ended. For example, on a socket stream and lots of other streams, you don't know you've hit the end of the stream until you've hit the end of the stream. So returning 0 is the only way to know an EOF. When you're writing, you can close the stream for writing, which signals an EOF to the reader. That TCP socket has a half close when you can close the writing end, and the other end will receive the EOF on the other side. It's used. Compression stream will know that that's when it needs to finish everything, write the footers. HTTP chunked stream has a specific thing that says EOF. That's when it knows how to do it. Flushing should not affect the data. All flush does is empties the buffers. It doesn't mean to write to complete the compression block or to finish the stream. You should still be able to write after you've flushed. So the main functionality, you can read, you can write, you can flush, which is emptying your buffers. You can seek around, you can find out the size, you can truncate, shorten, so set a file to a certain length, shorten or lengthen. You can find, which means give me the offset from my current position to either a character or another string. You can unread, which means that I read some data, I didn't really use it, I want to put it back on the stream to allow somebody else to read that data. You can close read or write directions or both at the same time. And you can cancel a read or write that's in progress on another fiber or thread. Now, not all of the streams supports each one of these operations. You can query a stream and say, do you support truncate? Do you support unread? And the base stream's a socket, really only supports read, write, and cancel read and cancel write. It doesn't support anything else. Well, it supports close. So you add the filter streams on top to get that additional functionality. By layering a buffered stream on top of a socket stream, you get find functionality and unread functionality. And then whatever you layer on top of those, depending on what they do, they might actually remove functionality. But it's just you create a stack of streams to do exactly what you want it to do and change the data how you want it. So free functionality that you get is get delimited, which says give me a string up to this character. And you get that for free if it supports find. And the reason that get delimited is separate from find is so that, you know, get delimited, you kind of need your buffered stream on there so that you can do a look ahead. But we want the read to go through like normal so that other streams in between where you're doing the get delimited and the buffer actually see the data. So you have to support finds to do a get delimited, which does find, tell me where it is, and then do a regular read to that location. The other free functionality is tell, which is your current location of the stream. If it supports seek, it supports tell by just calling seek 0 bytes from the current position. There are some streams that support tell even though they don't support seek. So if a stream is counting how many bytes are going through it, it could support tell even though it doesn't actually support seek. So transfer stream, the only read-write loop you'll ever need. If you're reading data and writing it to another stream, you're doing it wrong. There's no need to do that. It's optimized. It's the best you can get. It supports doing a certain number of bytes. And you just shouldn't be writing your own read-write loops because you're wasting code. The other benefit to it is if you're using fibers and things are working on multiple threads or they can happen asynchronously, the read and the write will happen in parallel, if possible.
Presumably that means the read of the next block while I'm writing the previous.
Yes, yes. It can't write the one that it's currently reading. So it does the first read, gets that block, and then writes that block and reads another. Writes that block, reads another. When we get to EOF, then it will write the final block separately.